today I'm going to be doing a bit of a deeper dive into the architecture of OSM and talking a little bit more about the technical bits so that you can get a good understanding of the different aspects of OSM, the different components that comprise it, and a little bit more insight into what we're thinking about for Release 6. So I think we're all familiar with this slide. Just the pink box describes the scope of what OSM really encapsulates. So when we look at the ETSI diagram of the whole NFV ecosystem and all the architecture there, OSM really fulfills the requirement of what's covered in the pink box there. And so as we mentioned, my slide's actually a little bit out of date. We're now up to 120 community members. It's almost impossible to keep these slides updated because someone joins almost daily. The OSM governance structure, so just to give you a little bit of background on how we manage this open source project and keep it from getting a little bit unruly, we have a very rigid governance structure which we fortunately inherited from ETSI and other projects that are managed there. Across the top we have the leadership group, and the leadership group is comprised entirely of carriers. So that is how we really drive the carrier requirements into the community, is by having our top level leadership group comprised of the carriers that would consume the OSM as a product. Underneath that is the technical steering committee that's comprised of member companies, and our technical steering committee is a little bit different from the way things are run in the Linux Foundation. Membership of the technical steering committee is managed by merit, and in that however many lines of code your organization contributes, that's what wins you a seat on the technical steering committee, except for the chair, which is an elected position. And so it's only the members that are very active contributors are able to have a membership on the technical steering committee. And this is something that evolves over time with each release. We reevaluate the top 5 members across the last 3 releases of open source Mano. And that's how we determine the membership of the technical steering committee. So unlike the Linux Foundation, where however much money you've invested into the project determines your seat on the board or the steering committee, on open source Mano, your position is earned, and you have to maintain that position by continuing to contribute effectively to the project. Underneath that, we have our module development groups, which each have an assigned lead, and these are people that really do the hands to keyboard coding. Each of these different modules has a different discipline, and I'll get into that in a later slide, where they focus on that core component of OSM, so be it the resource orchestrator or the lifecycle management controller, et cetera, et cetera. These people really focus on that individual component and have governance over the contributions for that component. And so that module development lead is responsible for the features that go into those different components, being a bit of a tiebreaker when there's more than one contribution that might conflict or overlap, and deciding on where the integration points are for those particular modules. So OSM really has 4 core architectural principles, and we've had this since release 0, since the first day we started. And those principles are layering, abstraction, modularity, and simplicity. Layering in the sense that we have a certain organization of the way the project's structured so that certain pieces can be swapped out for others. So if we have, and we've had this over the course of the life cycle of the project, where certain features have been innovated faster than others, and so we pulled an entire module out and replaced it with something better. And it's very easy and very simple for the project to do this because it is so modular. And so that each of these different components has a very specific discipline. It's not very difficult to swap them out without really impacting the rest of the code base. We really adhere to the abstraction policy, where we have a northbound API interface that is used by both our web-based UI, our command line interface, and it also acts as a RESTful API. And this is the one interface into the entire project so that you can't really go sideways and influence individual components. Earlier versions of OSM lacked this maturity, and so as of release 4, we really firmed that up and consolidated everything in one common northbound API that's used by the whole platform, and it's the one entry point into the platform for how you control everything. And as I mentioned, it's very modular, and that we've broken it into these different components that have very specific functions within the platform. And so each of those individual components can stand on their own or be swapped out for something else. And finally, we like to think that the platform is simple and easy to use, and it's very consumable for people. In addition to running the Hackfest, we have reasonable yet somewhat minimal documentation on the wiki, and yet somehow we have these communities like the 5G communities and the research scientists that are able to just log onto the wiki, consume open source Mano, and go from zero to functional orchestrator in the span of a day. And so these people are able to author their own service descriptors, do their own deployments with very minimal involvement with the actual project itself, which is somewhat rare for open source communities. Typically, you see a lot of traffic on mailing lists or hitting a Slack channel saying, how do I do this? How do I install it? How do I even begin? We've had quite the opposite experience with open source Mano because we had a mandate from day one to make it pretty simple and easy to use. We've heard a lot about the OSM ecosystem. I personally think that this is a big part of OSM's strength in that we have a very broad ecosystem. So it's great to say, oh, there's 120 different member companies, but if you look at the cross-section of types of companies that are in the OSM ecosystem, all the way from tier 1 providers, multi-billion-dollar commercial vendors, VNF vendors, both open source and very large, and then we've got our academic community having this huge breadth of contributors really make the project that much stronger, and we can really marry the discipline from commercial vendors with the innovation coming from the academic research community. And so we'll make these slides available to you, so all of these links you can access and peruse at your leisure. So yeah, this slide again is my version is a few weeks old, and it's already missing a couple people from the OSM ecosystem, but the busy slide just gives you a good feeling for how robust and diverse the ecosystem really is. And as we mentioned before, OSM became, on its own, the project of choice, the orchestrator of choice for 5G research projects. And this was with absolutely no involvement of the open source Mano community or any of the executive. We didn't have to drive this or advertise or market to these people at all. They just Googled for something that would work for them, and it worked. And then just through pure word of mouth among the research community, all of these other people started using it, and now they're starting to collaborate with each other by using OSM as your orchestrator, which is a really, really nice side effect, and it's made for some very interesting demos and use cases, which you'll see later this afternoon. One of my colleagues will be presenting. And I know that we've really been hammering this point home, but why 5G research is so important to OSM is for a number of reasons. One is it drives innovative new features into the code base that the existing participants might not have even thought of because they're coming from the research community, so they're a little bit out there. We don't have customers actively trying to deploy this stuff, but it's the research community that's actively developing these new capabilities, these new technologies, these new bits of software, and these new paradigms and ways of thinking about deploying network services. These are things that we might not have come to for another couple of years when the carrier community was actively trying to deploy them. So it's really nice to see them coming to the project early and establishing the amount of innovation there. Next, it introduces new uses for OSM aside from basic telco NFV. So a lot of these 5G research projects are doing things that we hadn't even tried before inside the telco operator environments. And so we were pleasantly surprised with some of the use cases that they were coming up with because we hadn't even thought of them before. And it's made for some pretty interesting demos. And it really showcases the flexibility of the platform and the fact that you can use it to not only deploy, very standard network services that fit that traditional telco NFV paradigm, but all kinds of network services that, are a little bit more innovative, a little bit more bleeding edge. And it really shows the fact that any kind of cloud-based service, be it telco NFV or otherwise, is really possible with this platform. And even though we've positioned this as a very telco-centric project, there's nothing to stop you from using it for non-telco workloads. And the other feature that we really like is that it broadens and enriches the OSM ecosystem. And as I mentioned before, it makes our ecosystem that much more diverse, and I think it makes it that much more powerful. And it creates new avenues for collaboration. One of the great things that have fallen out of these 5G research projects participating is they start attending the OSM events, we start interfacing with them at conferences, and now they're starting to talk to each other and building new 5G projects that they hadn't really had an opportunity to do so before. And so we've been sort of that forum for them to start getting together and collaborating with each other that they might not have otherwise had. And some pretty interesting projects have popped out of it as a result. We also have a really interesting cross-collaboration with OPNFV. For those of you who have been in the telco NFV space for a few years, you should be familiar with the OPNFV project. And recently, it's somewhat pivoted to focus more on test automation. And they're doing some really interesting things that are a huge benefit to projects like Open Source Mano, in that it helps us automate our test bed as the project gets more and more complex, as our code base gets bigger and bigger. Doing full regression testing for every release gets a little bit harder. It's no longer feasible to do completely manual testing for every new feature that we put in there and do proper end-to-end testing of the whole platform. By leveraging stuff like what the test harnesses that OPNFV is building, it gives us an opportunity to start automating that end-to-end testing and doing things like nightly build automated testing and being able to test subsets of the code base without having to do a full regression test every time. It gives us a lot more confidence in our platform, but it also imposes a certain level of good code hygiene, where if you know that the code that you just contributed caused a problem, you're going to know right away because the testing is automated and you don't have to wait for someone to do a manual regression test. So this has been a huge benefit for us. So let's look a little bit at the actual architecture of OSM itself. And this slide's a little bit busy and might be hard to read from where you're sitting, but I'll go into the details in later slides. OSM is really effectively divided into runtime and design time components. And when we say design time components, we talk about the web-based UI that lets you compose a network service and modify a network service, or being able to author the Yang models directly in a text editor if you wanted to, or being able to import those models that you've generated in another tool. Then when you look at all of the pink boxes, that's our runtime scope. And so this is where we actually perform those deployments and those day 2 lifecycle operations. And so we have our network service orchestrator across the top. We have a separate module for VNF configuration and abstraction. And so this is really the application layer type configuration. Then beside that, we have our resource orchestrator, or affectionately called the RO, by the contributors. That's really responsible for all of the interactions with the Vim layers and the SDN layers. And so when you look at all of these together, it comprises OSM, but there's actually a lot of different pieces in there. And so as we mentioned before, it's a multi-layered model. And so each layer can provide a service object that is composed of many other smaller objects. And so by putting them all together, you can comprise a network service. But because the approach is so modular, you can have these little mini network services that stand alone, and then you can combine them in a service model to make a much broader network service. And so you can have a network service that's as simple or as complex as you like, and you can reuse some of those components. As I mentioned before, we like to keep things simple. And so we really aim to minimize those integration efforts with the VNF vendors and being able to build a network service descriptor in a very simple way. And so we have a very well-published, well-known information model that is aligned with the ETSI standards. it's aligned with the IFA and the SOL 6 standards, so that when we're building network services, there's nothing that's proprietary or really surprising in there. If you're familiar with the ETSI models, you should be able to compose a network service here, even in a text editor. And we did that on purpose, and it's important to us that we continue to not only align with the ETSI standards, but ratify them and send feedback back in to those standards where we've identified gaps. And because as we mentioned, the standards are a little bit behind what we're already implementing. And so we take that responsibility upon ourselves to inform those standards about what they're missing, so that they improve over time as our platform improves over time. And as we mentioned before, there's a unified northbound interface. There is one northbound interface that is used by the web-based UI, the command line interface, and the RESTful interface. It's all one common interface, and it aligns with the ETSI standard of SOL 5. We did this for a number of reasons. One, because we needed to be able to control access to the platform, and if we wanted to start doing things like role-based access, you can only really achieve that if you have one interface into the platform instead of other applications coming at it sideways and hitting individual modules. It has to roll up through one so that you can maintain things like authentication tokens, etc. We also did it because we realized this platform isn't a standalone be-all end-all platform. People will want to integrate it with OSS systems, BSS systems, and in order to do that, they need a standardized interface. Nobody wants to see yet another proprietary API that they have to develop against that might change without notice. OSM's made a commitment to continue to align to ETSI SOL 005, so as SOL 005 evolves, we have agreed to evolve with it so that if you have a SOL 005 compliant interface, it will work with OSM. This slide discusses a little bit about how we look at the different domains of networks. And so you'll see here on the far left at the bottom, we have the network functions themselves, the VNF, the PNF, and the HNF. We have our transport domain. This is a concept called WIM, which is maybe not as common across the whole industry, but this is like the wide VIM, so that it's the multi-VIM or the multi-site type architecture. And then we finally have our virtual domain or our VIM layer. And so OSM provides that abstraction from all of those different physical constructs. And so you can, by leveraging that one SOL 005 interface, you can deploy objects across all of these different components or these different domains without having to touch them individually and making for a very complex movement. OSM handles that workflow management for you. And so when this is just another representation of sort of the same thing where the OSM acts as that network service orchestrator that interfaces with the OSS BSS layer northbound, and then southbound interfaces with all of these different constructs to be able to build a network service. And so when we look at the concept of SDN and software-defined networking, this can get really complex because software-defined networking encapsulates both overlay and underlay networking. OSM manages that abstraction for you in that whether your VIM has SDN capability or not, OSM has the capability to be able to manipulate that SDN layer, whether it needs to go through an SDN controller that touches physical hardware or manipulate an overlay SDN controller that stays in your virtualized cloud. And so there are really 4 basic models for integration with SDN. And so open source Mano addresses all 4 of them to be as flexible as possible and give you as much choice as you like with what your VIM layer and your SDN layers are. On the far left, we have just the basic VIM with no underlay components or no underlay manipulation. And so it's got its own internal layer 2 networking. And it's you know, just a vanilla OpenStack or vanilla vCloud director in its raw form. Next to that, we have the second model where We have overlay SDN, but it's integrated with the Vim, and so the integration point with open source Mano is still with the Vim API. The next model is more of we call it partial SDN, where it has some underlay as well as some overlay built into the Vim layer, and by interfacing with the Vim layer, you're able to do those things in concert. So an example of this would be like a KVM-based OpenStack with the ML2 plugin that's able to interface with an OpenFlow network. And then finally, the fourth module, or the fourth paradigm for networking is for VIMs that don't have their own underlay capabilities. And so this speaks well to the VMware VIMs, where the VMware VIMs are not concerned with the underlay networks. As long as you have layer 2 reachability, they don't manipulate them. But sometimes you have a desire to manipulate them, especially if your VNF is forcing you to do it. And so open source Mano is able to interface directly with that SDN layer to build those constructs, even when your Vim doesn't have an interface to do so. So you can leverage any one of these 4 paradigms without even having to understand which of the paradigms you are using. So long as your Vim and your SDN connectors are built, are defined adequately in your network service descriptor and in your VNF models, OSM handles all of the details of being able to push those constructs down and build that network service for you. So the life cycle of OSM, it's been a long road, even though it's only been a few years. It's felt like a lifetime for those of us involved with the project. And as I mentioned before, we started with release 0 back in 2016. And we initially launched the project at Mobile World Congress. That's when it was announced. 2016 was only 3 short years ago. And so since then, we're coming up upon our 6th release. Release 5 was released in December last year. Release 6 is coming spring of this year. And so we've had some very significant releases, and these are very large chunks of code that we've dropped to be able to achieve all of the features and functionality we've had. And so going from an open source community that had, what did we start with, 5 members? 23 from the beginning. Now we're up to 120 in 3 years, and we've gone through 6 releases, and we achieved sort of what we consider production readiness around release 5. I think that's a significant achievement for an open source community, especially one that hasn't received a ton of funding, and it's really been very much a grassroots efforts driven by the operator community and embraced by the vendor community and now the academic community to be able to achieve all this. So I think it's a pretty significant achievement by comparison to other open source projects. So OSM Release 5, as I mentioned, we launched it in December of last year. It was a really ambitious release. There was a lot of new features in this release, and we're pretty proud of what we put in there. But just some of the highlights are the support for hybrid network services. So we introduced this concept of being able to manipulate physical network functions in concert with virtual network functions that exist inside of one network service. Because we all know that networks are complex, and being able to deploy an end-to-end network service means you're going to have to sometimes do things to your physical devices, particularly your layer 2 switches. And so we built this capability into OSM so that you can stitch all those together pretty easily. We introduced network slicing for 5G, and this was a contribution by one of our 5G innovation projects in EMEA. They approached us saying, we built this really cool thing, would you like to use it? And we of course said yes, because it's a great feature. And having this network slicing capability in the platform now since release 5 is a huge advantage for us, because now we can start deploying those types of topologies and really experimenting with what does that mean for a carrier? What does that mean when I want to deploy it in production, as opposed to waiting, a year or 2 years from now for when they actually need to deploy it. Now this feature exists in a state that's stable enough that they can play with it and really help refine what their requirements are going to be, and really help them define what those services are going to go to market are going to be. We extended our capability for multi-site inter-DC extension. This is that WIM, the WIM that I discussed. Being able to touch network services that might span across multiple data centers or touch multiple VIMs. This capability was built in as of release 5. We've made significant improvements, and we will see even more in release 6, around monitoring and policy. And so it became very obvious really early on that being able to monitor things and being able to accurately judge the health of your network service was key for service assurance. And so the role of the orchestrator doesn't really end after you've deployed a network service. That's just day 0. Yay, you got it deployed, good for you. But now you have to know, is it running? Is it running well? Do I need to do anything to it? And so the orchestrator really needs to know how healthy the service it just deployed actually is, so that the orchestrator can remediate if there's anything wrong with it. By pushing that responsibility to another system, you really take away the capability to do this type of closed loop service assurance, because then you open the door to say, now this other system would have to know about topology. It would have to know what the orchestrator deployed and where. Now it has to know about which VIMs are connected. Now it needs to know complex information about the network. And what we realized is it makes a lot more sense to let the monitoring systems do their detailed monitoring. There's always going to be a role for things like smarts or HP OpenView or whatever you've deployed. There's always going to be a role for that type of micro telemetry monitoring. But including the orchestrator in those monitoring and being able to have an interface to capture alerts, to capture events, and to be able to trigger events based on policy, and being able to define things like, here's my network service descriptor, and here's the KPIs right in the model that define how I determine that it's running, because it's different for every network service. If you have a VoltiCore, it's monitored different and has different KPIs for like a CDN network. And so being able to define that at deploy time and have your orchestrator aware of that is really key in being able to do that closed loop service assurance and automate all of those day 2 lifecycle operations. We've also increased the modeling of the VNF networking. We've added some service function chaining capabilities, which I'll talk about a bit in a minute. Multi-VDU relations. What we learned is that initially this concept of a VNF, everyone just assumed it was one VM. But when you look at more complex VNFs, it's not one VM, it's many VMs, and how they're interconnected is not necessarily very simple. So being able to define that and model that well inside of your VNF descriptor was a feature that we added. Actually, it was before release 5, but we really firmed it up and documented it properly as a release 5. And we greatly improved the user experience in release 5. Previous versions of OSM had a UI that was sort of borrowed code from another open source project, and it didn't necessarily have all of the features that were available in the REST API. And so what we've done is said, all right, we're going to make a UI that uses that Sol5 northbound interface, and it's going to actually leverage that so that the experience that you get from the command line is the same experience that you get from the UI, and being able to unify that into, it's a much crisper, much better looking HTML5 based UI as well. And it's actually got a GUI composer and a little bit better at rolling up all the logs. And we're going to see even more improvements into that in release 6. So let's go a little bit deeper into release 5 and exactly what's under the hood. So this slide I think you've seen before, where it just sort of talks about the core themes in release 5 and what we were really going for when we were driving the new features. As I mentioned, we added network slicing, the multi-site extensions, monitoring improvement, improved modeling and networking, so more things you could do with it, including the service function chaining and the PDUs. And we really improved the user experience, not only with the UI and the command line tools, but we also made it a lot easier to install. It used to be kind of an arduous process to install from source, and there were a bunch of dependencies you had to download, and if you lost your network connection halfway through, it was somewhat unobvious what you had to do to remediate that. Now we have Vagrant builds, we have Docker builds available on Docker Hub that you can just download and install them, and they will just work. It comes as a much smaller footprint that's already somewhat configured, and all of the components that you need are comprised inside. All the dependencies are in there, so that you can just deploy it on your workstation and start playing with it right away, instead of having to sit there and hack through a series of log files to figure out why your download failed. So when we really look at which components compose OSM, I think this slide summarizes it really well. So we have our northbound interface, this SOL 005 compliant interface, and this is a RESTful interface. And it's leveraged by both a lightweight UI / service composer and the OSM client, or you can hit it natively as a RESTful API, because it adheres to all of the rules that come with that. And so this northbound interface consumes the OSM information model and then is the main conduit for how we push those network services into the platform and interface with the Vim and SDN layers. So as we go further down, we have the LCM. This is the lifecycle control module. This, in conjunction with the VCA, really handled the configuration of the software layer of the VNFs, as well as the day two lifecycle management of those VNFs. And so there's hooks in here that help us do the monitoring and telemetry at the application layer and not just at the infrastructure layer. Because that's always something that was really missing with monitoring of network services in general. We always had a tool that could monitor the infrastructure layer that was usually provided by the infrastructure vendor. And we'd have a tool that could monitor the application layer in the VNFs, which was usually provided by that vendor. But never the two did meet. And so it was very difficult to determine the health of a network service, because you had these two islands of monitoring and management that didn't really interface with each other. And so OSM sort of provides the glue between being able to marry what's happening on the infrastructure layer with what's happening in the app and correlate some of that stuff, so it's a lot easier to do root cause analysis of failures and remediate them. And so we manage that through these newer modules called MON and POL. So POL stands for policy, and that's where you get to set things like the thresholds for certain KPIs, how you expect a network service to perform, different access rules. And we've made this module extremely flexible so that you can embed some of these policies even as metadata in your network service descriptor, so that we don't really fence people into being stuck to monitoring only a certain few things or being stuck to a few KPIs. We really leave the door open to monitor what's important to you and set policy for what's important to you. And so if your company's SLAs are bound not by throughput but by number of users, you can configure that here without having to change the core of OSM or how it works. It's just a minor change into your deployment model, into your VNF descriptor, to be able to change how those things are monitored and what parameters are monitored. And we stitch the whole thing together with a common Kafka bus, which these different components can subscribe to and pull off the bits that are relevant to them. By standardizing on one bus, it gives us a lot of flexibility to be able to have these different components talk to each other. And so it gives us a lot of flexibility, and this is really the secret sauce as to why we're able to achieve closed loop service assurance, is because they use a common bus. And so if an alert or an event is caught by the MON module, it's able to push something onto the Kafka bus that could be consumed by the lifecycle manager to be able to remediate that network service. That wouldn't be possible if they were all using separate buses. And so by unifying all of this with a common bus, it gives us the flexibility to have these different modules talk to each other, but in a standardized and controllable way. So this slide really talks about some of the extensions and the bolt-ons that we've added from other open source projects that make our monitoring and closed loop service assurance really possible. And so we've contributed an elk stack here, which uses upstream Elasticsearch, Logstash, and Kibana, so that you can start visualizing what's happening with your network, and you can start looking at really cute graphs that will show how your network services are performing. And we've also added the performance and monitoring stack with Prometheus and Grafana. It's the same kind of thing that you can start looking at in a visual way how your network service is performing instead of just tailing a bunch of log files and hoping that you catch something. This is a really powerful tool that lets you roll up and visualize exactly what's happening with your network service. And because we have such a modular and a standardized API, we can easily add other components here as the ecosystem evolves, as different tools pop up that might be a little more powerful than the ones we've used. We leave the door open for integration points, and it's very easy to bolt them on. Looking at the OSM stack, these are all of the different components that we leverage inside of OSM to be able to make it possible. And so you'll see we use the MongoDB, we use upstream Kafka. It didn't make sense for us to write our own database or write our own bus. Why wouldn't we just use some best-of-breed open source technologies? And so we consume those things from the upstream, and we only author the components that we really need to that add new functionality instead of reinventing the wheel that someone else has already mastered. So now let's talk a little bit about network slicing and how OSM has implemented it. How are we doing on time? Oh, these slides advance themselves. Back you go. And so a network slice can span separate VIMs and physical functions. And so and the concept of a network slice really traverses your entire network infrastructure end to end instead of being limited to just one construct. These slides auto build. And so if you oh, come on. So if you look here, we'll let it build again as I talk through it. The VNF package and the network service package, now it's not going to build. Yeah, with the definition from the northbound API, it hits the northbound API, contacts the resource orchestrator, which then pushes those objects into your NFVI layer and builds your network service. And so this concept of a network slice that can traverse multiple VIMs, multiple physical networks, is already built natively into open source Mano as a result of one of our 5G research contributions. Service function chaining, it's been available as an experimental feature since release 3, but release 5 really saw us firm it up into a usable feature. Some of the requirements for it are your Vim layer has to be OpenStack Queens or older or newer with the networking SFC plugin embedded or installed. Right now we support asymmetrical chains where, and that means we support chains that go from A to B to C, but the reverse path is not necessarily implied. That would be a unique asymmetrical chain. And right now we're leveraging the SFC encapsulation using network service headers or the NSH constructs that is defined by IETF 1490 something. I forgot. It's on our wiki. So the first test that we built with OPNFV in the test automation was actually leveraging this SFC module, or this new SFC capability that we built into it. So you can look at this on the OPNFV wiki, but it talks about all of the different automated tests that we do to deploy and test and tear down a network service that leverages service function chaining. So it's pretty exciting that we were able to automate what is perceived as a somewhat complex network topology right out of the box with this integration with the OPNFV cross, what was the CI part? I forgot that too. But the OPNFV automated testing harness that they built. So what we wanted to demonstrate is if we can do something this complex, we can test almost anything. So this was the first use case that we really did, and we were pretty pleased with the results. And again, this was minimal involvement by the OSM community. The OPNFV community approached us and said, we see you have this capability. We built this test harness. Want to test it with us? And of course we said yes, because it was really good. So this was another example of how well the community is really self-serving and self-sufficient. So yeah, to talk a little bit more about the service function chaining capability, we added some features into the information model and the resource orchestrator to make it possible to have separate ingress and egress points. Because as we know, when you're going through a VNF, it doesn't make a lot of logical sense to be able to always go in and out of the same interface point. In the case of firewalls, you'd have multiple interfaces on multiple different networks, and so you'd want to be able to go out the door that you didn't come in. So we added that feature into the information model. And so as I mentioned before, currently only asymmetrical chains are supported. This is not necessarily a limitation of OSM, but it's also a limitation of how IETF has defined how it works and how the SFC plugin for OpenStack is currently implemented. And so there's a little bit of work that needs to be done there before OSM can support this. That unfortunately rests outside of the OSM community. The concept of non-transparent service functions are not supported. And this is, again, a limitation more in the standards and how the plugin's implemented than the capabilities of OSM. OSM currently has the capability to model these types of constructs today. The information model will support it when the underlying technology supports it. And currently not supported is this concept of branching and joining. And so if you were to look at, say, for example, you deployed a network service with that leverages service function chaining that defines the pink line. And so you go and deploy that, and you have a service function chain that goes from VNF 1 over to VNF 3. If you then wanted to insert another VNF into the path of a running service, this is something that's not currently supported natively out of OSM, but there are workarounds to achieve it if you really wanted to. But we're looking at making it a lot easier to do this in future releases. And the concept of service function tap, this is not currently supported in OSM. This is a pretty simple change for us to be able to support it when the use cases warrant it. But this is really handy for things like an intrusion detection system that wants to sit there and analyze every packet that traverses your network. So you have to put a passive tap into your network service to be able to do that without actually interrupting the flow of traffic. So this was something that we have slated for a future release as well. And the SFC Management API, as is defined, there it is, 7665. I was way off. So what we've implemented in OSM adheres to what's been defined by the RFC 7665, and we haven't deviated from it or done anything crazy. We wanted to adhere to what's the published, documented way to do it, so that people understand what the user experience is going to be when they actually leverage this capability in our platform. And so this is just a bit of a very hard to read visualization of the kind of things that of the SFC Management API. You control all of this stuff from the northbound API in open source Mano, whereas without open source Mano being in the mix, you'd have to touch all of these different components to be able to make this possible. And this can get very complex very quickly for even the most basic network service function chain. But OSM makes it really simple. And what we're trying to illustrate here is that you have one touch point and one definition in your data model to be able to achieve a complex network service. So network slicing, for those of you who aren't familiar with that, you may want to come and join the rest of us in the real world, because I think that this buzzword's been used pretty extensively. But the way we address network slicing is we create different network segments that don't interfere with each other that can be pinned to separate network functions and separate capabilities and separate services, so that you can leverage the same physical and even the same virtualized infrastructure, but have these network services not interfere with each other. So that's how we really address, and that's how we think about network slicing. I know a lot of people have different definitions of that, but this is how OSM approaches it. And so when we look at the ETSI framework, the ETSI identity framework for network slicing, this is really how we've addressed it in the OSM platform, and we've leveraged the Eve definition of 0.12 of that, where we talk about how a network slice subnet can be considered an NFV network service. And so when you think about it as a network service, then it becomes really easy to nest them and encapsulate multiple network services inside of one slice. And that was really the construct that we used, and that's what made it so easy for us to implement this into OSM, because the construct of network service already existed. So all we had to do was define an additional overarching construct where we could start nesting these things inside of each other and call it a slice. It was actually not a lot of work to do this. So this slide gets into a little bit more of how we've actually implemented it and how it interfaces with the work in 3GPP. When you look at how we have the network slice that touches the network service and then reaches out to the network slice subnet, which could contain these separate objects, and this concept of being able to nest them is what makes it possible. So when you define, the way we define a network slice instance is a set of network functions and the resources for these network functions, which are arranged and configured, forming a complete logical network to meet network characteristics. And so a network slice instance is effectively a network service that's been defined for specific functionality. The network service instance contains the network functions, the information relevant to the interconnection, so how this network service interfaces with another network service, so you could chain multiple network services together. And it's defined by the network slice template. So when we look at a network slice template, this is kind of a visualization that you might have trouble seeing from there. But this is just one example that we built for one of our Hackfests that really demonstrates the network slice capability. And these are all the various components that comprise it. So we have our VNF definition, as well as our VLDs, and we create a network, we create a network slice that traverses multiple VIMs. So the network slicing assumptions, we had to make a few of them when we implemented it for OSM. And so this really summarizes that here. The network slice subnet is supported by the network service, whether it's shared or not. So you have to at least have a network service before you can take a slice of it. That one should be somewhat self-explanatory, but it's important that we define that, because I think some people were trying to define a network slice or define a slice subnet without actually defining a network first. And you can't really have a slice of a network without having a network. The network functions can be physical or virtual or both. It doesn't matter to OSM. The constructs are agnostic. It must include a 5Q1 as a constraint. There are two types of information model resources for supporting slices. So these are things that we've added to the information model to be able to support network slicing. The network slice template and the network slice instance. When you think of the concept of VNF descriptor, which is a subset of a network service, this is similar to the same thing, where the network slice template defines the generic definition of a network slice, and the network slice instance defines the specific implementation of one. The network slice template must have connection points, similarly to how a network service has connection points. You need to be able to reach your network slice. Creating it off in the ether without any interfaces on it is not entirely useful. You wouldn't be able to interface with it or do anything or push any traffic across it. And the network slice service can be interconnected with virtual links, which are described in the network slice service forwarding graph. And so this is a standardized construct that you can read up. There are links on our wiki about it. But these are all the assumptions that we made when defining the network slices, and so we had to document all of these assumptions when we were implementing it, so that it was very clear as to what it is we built. Because, as we all know, network slicing is a very ethereal concept that's defined very differently by different vendors. And so this describes the implementation of how OSM did it. So when we touched the different components to make network slicing possible, these are the ones that we had to modify. Obviously, the northbound interface and the information model. We had to add some constructs that didn't previously exist to be able to find a network slice. And the lifecycle control module to be able to deploy and create these network slices and manipulate them. But that's it. So by just modifying a few of these components, because OSM is so modular, we were able to deploy a pretty complex thing like network slicing in a pretty minimal and unobtrusive touch to the code. And so if you want to learn more about OSM, I highly, highly recommend that you take the time to attend a Hackfest, and if you can attend in person, then I think it's a really good idea for you to leverage some of the resources we have on the Hackfest online and try it at home. So we publish all of the instructor slide decks. We publish all of our test code and test harnesses and sample network services and sample VNFDs. You can download all of those on our wiki. So if you're not able to go to one of the instructor-led events, we give you all the resources so that you can play with it at home.